This is the fourth set of notes in the ES1 unit. It's called Nature of Science, Laws, Theories, and Pseudoscience. You can find all of my notes videos on my website, btrachy.home.blog. In this video, you are going to be writing down all of the text that is orange. You do not need to write down text in any other color, although you may if you like. If you find yourself needing more time, of course, remember you can always pause the video to give yourself time to write. So the title of the notes is just the nature of science. Write that at the top of the page, or if you're typing at the top of the slide. And this is a title, so it should be a little bit bigger than the rest of the text. So, scientists are working to understand the world and the universe. They base their understanding on evidence. They communicate with each other and check each other's work through peer review. If you are a professional scientist of some sort and you hope to publish a paper, you have to submit that paper to a panel of experts to get it approved in order to be published in a reputable journal. Scientific ideas are durable yet tentative. By durable, I mean they have been checked for accuracy and validity over and over again. That's the panel of experts. By tentative, I mean it's always subject to change. If new information is presented and proven, ideas are able to change within science. Scientific laws. A scientific law is a description of an observed phenomenon. It's a statement based upon empirical data, which is observation and experimentation. It's usually limited to a certain set of circumstances, such as being on planet Earth. Often they involve an equation. Like all other scientific principles, they're subject to change with new evidence. Examples of scientific laws, you only need to write the first one down, but there are several here. Newton's 3 laws of motion. The second law is an equation. The universal law of gravitation, which can be shown by an equation. Kepler's laws of planetary motion, Hubble's law of cosmic expansion, and the various laws of thermodynamics. Theories are different than laws. Scientific theories are explanations of observed phenomenon. They usually are a statement that can be tested, and they cannot be reduced to an equation. Like everything else in science, subject to change as new evidence is proven. Examples of scientific theories include evolution, natural selection, relativity, continental drift, and the Big Bang Theory. Pseudoscience. Pseudoscience is a collection of beliefs or practices mistakenly regarded as being based upon scientific evidence or the scientific method. Often it's very interesting topics, but they don't hold up to peer review, independent research, or really any kind of scrutiny. Examples of pseudoscience include eugenics, Bigfoot, ancient aliens, vaccines are bad, the Loch Ness Monster, flat Earth, and phrenology. That picture is actually of phrenology. Some people used to believe that you could tell things about a person's personality by the shape of their head. And that was pseudoscience. Let's take a little bit of a closer look at the flat Earth's theory because it's gained some prominence in the media somewhat recently. The flat Earth theory states that the Earth is flat because it looks flat from a person's perspective. They say that all NASA photos are photoshopped. There are some kind of half-baked experiments online, and people who believe in flat Earth theory tend to be distrustful of scientific agencies funded by the government. But flat Earth theory is pretty easily debunked. There's some different ways that flat Earth theory can be debunked, I'm going to go over here. The first one is ships disappear over the horizon bottom first. You may never have noticed this, but if you're ever in a place where at a body of water, and the body of water ends at the horizon, like at the ocean, where you just see the water until it ends. If you watch a ship that's moving away from you, there are times when the bottom disappears and you can see the top. Another way that flat Earth theory could be debunked is um, by time zones. If the Earth were flat, it would always be daylight on the whole thing. The fact that the Earth is round is what gives us our 24-hour day with half of the Earth in darkness and half of it in light. If you call someone in California um, at like say 8 a.m. our time and it's 5 a.m. there, it'll be dark still there and light on the East Coast. Lots of photographic and video evidence. Another way that shows the Earth is round is the movement of stars across the night sky. They all spiral around the North Star, and that's because of the spinning of the Earth. And this bottom picture is a time-lapse camera of stars moving across the sky due to the spinning Earth. And think about it. If the Earth were truly flat, if you had a powerful telescope, you could see the other side of the ocean, but you can't. And the machinations of the solar system with um, the Earth revolving around the sun and rotating on its axis has allowed, and the moon revolving around the Earth has allowed scientists to predict every solar eclipse with accuracy. Remember, in August of 2018, they knew that the solar eclipse was coming. If the Earth was flat, that would be a little more mysterious. So for the notes, I just want you to write down one of the ways that flat Earth theory can be debunked. But probably the most important part about pseudoscience is that if new, reliable, valid, repeatable evidence was presented that supported something like Bigfoot existing, the scientific community would have to accept it. And that's the nature of science, that the knowledge is tentative. There's always new information coming up, and certain things are evolving. So tentative means subject to change with new evidence. One example of scientific ideas being subject to change is that the giant squid was once thought it was to be a mythical creature, but then an actual specimen was found washed ashore, and now it is cataloged as an actual creature that exists. Another example of scientific ideas being subject to change is continental drift. When Alfred Wegener first proposed the theory of continental drift, people thought he was crazy, but it turned out he was right, and now the theory is accepted. Same with Darwin. Evolution was considered a crackpot theory and sacrilegious, but over time, more and more evidence supported the theory of evolution, and now it's widely accepted. So, I also want you to write down one example of scientific knowledge being subject to change. Your choice. My favorite example is the giant squid. So scientists think of new questions to answer. They find the answers to the questions by collecting data under controlled conditions, manipulating particular variables while keeping other things constant. That's how new knowledge is created. And something important to remember is that there's two types of data you can collect. There's quantitative and there's qualitative. Quantitative is always dealing with numbers. An example is that there's 20 students in a room. Qualitative is an observation that's not numeric. For example, Steve is wearing a yellow shirt. One way to remember this is that there is an N in quantitative, and N is the letter that begins the word numbers. So the N in quantitative stands for numbers. Qualitative is not numeric. And so here is an example of the way this notebook page would look if it's typed, and you can pause the video here and catch up on anything that you missed. And here is my handwritten version with a little giant squid drawing. And so ideally, if you're handwriting it, it's possible to fit it on one page. And it looks better on your slideshow if you do it horizontally like this. All right, that's it.